Hi guys, we are going to do trigonometry, and according to this introduction that you'll get in Siavula, that is everything mathematics. It says trigonometry deals with the relationship between the angles and the sides of the triangles, meaning we are going to check how the angles and the sides of a triangle are related. We will learn about trigonometric ratios in right-angled triangles, which form the basis of trigonometry. Now, meaning, in order to understand trigonometry, we are first going to deal with the right-angled triangles. Now, there are many applications of trigonometry. Of particular value is the technique of triangulation, meaning if we triangulize stuff, then we become better person in understanding how it works, which is used in astronomy. Now, meaning triangulation is used in astronomy to measure the distance to nearby stars. You cannot take a measuring tape to measure the distance between stars. In geography, to measure the distance between landmarks, and in satellites navigation system. GPS, that is global positioning system, would not be possible without trigonometry. Other fields which make use of trigonometry include acoustics, optics, analysis of financial markets, electronics, probability theory, statistics, biology, medical imaging, that is CAT scan, and ultrasound, that is used in medical imaging, like the ultrasound. Chemistry, cryptology. Now, cryptology it deals with cryptography, that is cryptocurrency is part of that. Meteorology, oceanography, land surveying, architecture, phonetics, engineering, computer graphics, and game development. Now, all these fields of study need the knowledge of trigonometry. That is why we see this image here of a satellite orbiting. Now, it says the figure, an artist's depiction of GPS satellite orbiting the Earth. There are at least 24 GPS satellites operational in any one time. GPS uses an application of trigonometry known as triangulation to determine one's position. The accuracy of GPS is to within 15 meters. So guys, this is the thing. Now, in order to mark up or to know how this works, you can click here and see the video on how the history, that is, the following video covers the brief history of trigonometry and some of the uses of trigonometry. Now, I'm going to click on this and then let you see what it entails. So guys, nothing on this planet happens without mathematics. So in order to be in the know, you need mathematics. And mathematics as a science, it has different parts. That is algebra. You have geometry, which is Euclidean geometry. And then you have trigonometry. So let us just wait for it to open. Okay, and I would suggest we leave that, but you are going to get everything here. Okay. Yeah, let us start first with similar triangles. Now, when are triangles similar? They will be similar if they are equiangular and if the sides are in the same ratio. Now, let us look at this. Triangle ABC, ABC, and DEF, GHK. Look at these triangles. Angle A is equal to angle D and is equal to angle G. Angle C is equal to angle F and is also equal to angle A. Whereas angle B is equal to angle D, angle E, and angle H. Now, if the corresponding angles are equal, then the triangles are said to be equiangular. Equi from the word equal, angular from the word angle. So equiangular triangles are triangles having equiangular, having their corresponding angles being equal. So let us check through observation. It says in the triangle below, ABC is similar to EDF. This is written as the sign of similar is like this. 3 parallel lines sloping downwards. This angle is equal to that angle, and angle A equals angle D, angle B equals angle E. Then, if this is the case, that means it is possible to deduce the ratio AB, which is AB over BC, is equal to DE over EF. Look, AB, and then this one is DE. AB, DE. This sides here, on the left-hand side, you'll have this, the sides of this triangle, that is ABC, and this side is FDE. So AB corresponds with DE, BE corresponds with EF, and then CA corresponds with FD. So the ratios are put here according to their correspondence. So AB, it's AB over DE, DE, AC, AC, then it corresponds with DF. That is how the ratios are written. So let us go forward. If we look at this, what are trigonometric ratios? Let us first start with a ratio. What is a ratio? A ratio is an answer that you get when you divide two numbers, two or more numbers. So if you had 2 divided by 3, the ratio is 2:3, which is the same as 2 over 3. So let's take a triangle like this. It's a right angle triangle. Then what is trigonometry? Trigonometry is the relationship, is a mathematical perspective where the relationship of the sides and angles are dealt with. So here we have an angle that is theta, and then we also have 90 degrees. So according to, if we take this angle as a reference angle, we have AB, which is opposite to this. That is why it is written opposite. And the hypotenuse is always opposite to 90 degrees. and that is the longest side of the right angle triangle. And adjacent is a side which is the base side of that particular angle of reference. So now we get to the trigonometric ratios. If we take this, we have sin. If you look at your calculator, you will get sin, cos, and tan. This is sine, cosine, and tangent. Now, these are abbreviations, guys. So what is sine? Sin or sine is always a ratio. The ratio is always opposite over hypotenuse. It's opposite, which is AB over hypotenuse. Hypotenuse is BC. Now, the ratio of sin of this angle is this over that. And then, of course, it's adjacent over the hypotenuse. And then lastly, we have tangent. Tangent is opposite over adjacent, which is the opposite, because we have theta as our reference. Here is our reference. So it's opposite over adjacent. Opposite over adjacent. That will be the tangent of this. So I also have an acronym of this. Now we come to a conclusion that you also have an acronym like SO-CA-TOA. This is a mnemonic technique for remembering the trigonometric ratios like sin. It's SO, which is opposite, O for opposite, and H for hypotenuse. And then CA is cos, it's CA, which is adjacent over hypotenuse. And TOA, T-O-A, TOA, it's opposite over adjacent. So in order to remember this, just make sure that you remember SO-CA-TOA. And there are others which are called cosecant, secant, and then cotangent. So in all, that is SO-CA-TOA, CHO, SHA, CAO. So guys, if we are given this, we have theta here, and then alpha here, and then 90 degrees. This is a right angle triangle. Now, let us just make sure that we know where our hypotenuse is. Now, the hypotenuse is always the opposite and adjacent of the sides must be labeled according to, with respect to the angle theta. That is this angle. It will be there. But you can also label them in connection with alpha. So this is theta, and that one is alpha. Right. Now let's get to this. If you look at this triangle, you'll find that the point of reference, that is the angle of reference, is theta. Now, opposite is this, and then this is your adjacent, which is the base, and then the hypotenuse is always opposite to 90 degrees. That is how you will get to know this. So let us check this. We are now given this. It says complete this. We are given the diagram, and I'm going to draw it and then reflect it on the worksheet. Yes, this is C, and this is B, and that is A. And then the question says, complete the following. Complete. So, number one, it's sin A B, and this is A, B, sin A, cos A, tan A, tan A. Okay, let me just do this. Right. Let me just do it. Yeah, and then we have this. You have the sign of this. Then what is the sign of this? This is a right angle triangle. And then what is the sign of A? The sign of A is here. Meaning, if you don't see it quite correct, just make sure that you invert this. Then the sign of A is opposite. And then this is always the hypotenuse. And this is the opposite of the sign of A. And the opposite of sign C is this one. So the point of reference is very important, guys. So our point of reference, angle of reference is A. So what is the sign of A? Remember, so, ka, twa. That is sin, cos, and then tan. So let's start with sin. Sin is opposite over hypotenuse. That is the opposite of A, which is BC over, and then H, that is the hypotenuse. The hypotenuse is AC. This is called a ratio. It is called a ratio. This is a ratio. Now, sin A is a ratio. That is why we call this a trigonometric ratio. So let us get to this one. The cos of A, cos is ka, adjacent over the hypotenuse. Now, what is the adjacent of A? Is this one. From here, adjacent, the base of A. The base of C is this one. So the base of A is this. That is adjacent, which is AB over the hypotenuse. Hypotenuse is AC. So that is another trigonometric ratio. And then tangent. Tangent is opposite over adjacent. The opposite of what? The opposite and adjacent of angle A. Now, opposite of angle A, opposite is BC. And then over adjacent of A is this one, and that is AB. So that is how you get the trigonometric ratios. Now, say for an example, it is given that this is 4, and this is 3, and that is 5 centimeters. The magnitude, let's say the magnitude are in centimeters. Now, what are we gonna get? This will be equal to BC. BC is 3. It's 3 over AC. AC is 5. Therefore, the ratio will be 3 over 5 according to the magnitude of the size. Remember, we have to find the relationship of the angle together with the sides. Now, for this one, it will be AB. AB is 4 over AC. AC is 5. Then this one, BC. BC is 3 over AB. AB is 4. Now, this is how this is equal to 0.75, and this is equal to 0.8, and this is equal to 0.6. So if they say correct to 1 decimal place, you know it will be 0.6. But if they say to 2 decimal places, you know you will have to add 0 here so that you can have 1, 2 places. So guys, that is one of the realities that we have in mathematics. Mathematics is life, and what we need to do is we need to practicalize mathematics. Mathematics is a reality. It happens in our daily life. So that is why we need to use it. So let us just check this. We also have the sign of C. Sign of C, that is D. For D, we have it's sine C, and then E cos C, and then tangent C, okay? Tangent C. Fine. C. Here is our C. Here is our C. Sine, it's opposite over hypotenuse. Opposite of C is 4 over the hypotenuse is 5. And then the cos of C is adjacent over the hypotenuse. Adjacent is 3 over 5, which is the hypotenuse. Over 5, the hypotenuse. And then the tangent of C is opposite over adjacent. Now let's look at our opposite. Opposite is 4. Then we have 4 here. And then over opposite over adjacent. Now our adjacent is 3. So this is it, guys. Now remember, our point of observation, angle of observation is very important in order to get the real values or the real ratios, trigonometric ratios. So this will be the introduction, and now we are going to get to the practical part of it after this lesson. Thank you, guys. Would you please speaking alone? Lekai? I'm not. Kids, I'm Rupi. AM. Why don't know what's on there? Oh, Mahadia Dati Makalo. Oh my God. Who's on there? I'm not. Kids are Katidia. Kimudu, Pumole different to one see. Okay, khatsedi ya motho. Sharp. Thank you. Oh, ke ntho. Mradi ya timakala. Mangas, o rutsere phone ya hae jwale o bona dinomoro mo. A ra utlwa hore na ke tsamaya. Because ka kgolwa o ntsa bona di-contact a ne ntse re communicate. Ke re a bontsha history. O motho eno a tlwaetse ho bua le motho eno.